Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Now students, let us solve the next question, question number 3 of JEE Advanced Physics paper 2017. Students, let us solve the next question, that is question number 3. It says that block M hangs vertically. This is a block M which hangs vertically at the bottom end of a uniform rope of constant mass per unit length. It's a rope of constant mass per unit length, that is we can call it lambda or mu, whatever you say. So that is constant. So this is mass per length and that is constant for this rope. The top end of the rope is attached. This is the top end of the rope attached to a fixed rigid support at O. A transverse wave pulse 1. This is pulse 1 of wavelength lambda naught is produced at point O on the rope. The pulse takes time t OA, because to reach A it will take time t OA to reach A. If the wave pulse of wavelength lambda naught is produced at A, point pulse 2 without disturbing position of M, so the M is not disturbed, only the wave pulse is reflected back. If the wave pulse of wavelength lambda naught is produced at point A, this is pulse number 2, without disturbing this mass, it takes time TAO, so this pulse has to travel till this point O and it takes time TAO to reach point O. Which of the following option is or are correct? The time TAO, TOA are equal. So to see whether the time taken by the pulse 1 to reach this place and the pulse 2 to reach this place is same or not. The length is same, but then we have to see whether the time is same or not. Then we have to see the velocities of the two pulses 1 and 2 are same at the midpoint of the rope. That we have to see whether we are having same velocity at the midpoint. The wavelength of pulse 1 becomes longer when it reaches point A, whether the wavelength is longer over here. The velocity of any pulse along the rope is independent of its frequency and wavelength. That way to analyze everything. So I'll write that if I have a rope like this, which is uniform, fixed at this end, this point is O, and a mass is attached here, that is M. This is having linear density mu, this rope, and this is the midpoint. Now the pulse is one pulse is traveling this side from this to this, another is from here to here. So one pulse is moving like this, another pulse is moving up. This point is A, so O to A in the journey of pulse 1 and A to O, the pulse 2 is moving. The time taken here is TOA and here is TAO. Now we have to find the expression for velocity. Let us find the speed with which the pulse will travel along the length of the string. The velocity is of a transverse wave is given by the tension per unit mass. Tension per mass per unit length, that is tension per linear density. Now I'd write what is the tension created if I consider any distance, say x from here, say at any instant, suppose at a distance x, if I consider small element of dx from this lowermost point A, then at this length, what is the speed? I will assume that the speed is constant in this path, because the speed depends on tension, and the tension varies along the length of the rope, because if I move from A to O, the tension increases, and from O to A, tension will decrease. So A to O tension increases, and O to A tension decreases, so velocity will also change. So then the velocity of two pulses are at the midpoint is same. That will check it out. The velocity of any pulse along the rope is independent of its frequency. That will check. But then what is the tension for any v? Suppose the velocity here is v. That v here is the tension at this point, and the tension in the rope at this point is because of the weight mg of the mass that is suspended here, and the length this mass due to this length x. This length x is lying below this displacement, this rope dx. So therefore this length x will also contribute to the tension. So therefore I will write that tension will be the sum of mass. This is the weight of this one and weight of this length of the rope, that is mu x into z. This is the tension divided by mu root. This is the expression for velocity in between these 2 points from in the displacement of dx. So in this small displacement dx, the velocity is assumed to be constant, and if I want then I can write that this velocity is dx upon dt. Supposing that it takes time dt, then v is dx upon dt, and this v dx, this time I will write time is dx over v, because I am interested in time. So if I integrate this expression, the time I'll get from O to A or A to O is dx divided by the v I'm getting is mg plus mu xg divided by mu the root, and I will take the integration of this. This is a constant that is taken out, and this one I have to integrate. What is going to change? Because nothing is going to change, because my limit is dx is from, if I consider the length of the rope is L, supposing that the length is L, then from O to A or A to O, this will remain the same. So time will remain the same. So this time T OA I find, or I find this AO I find, this will remain the same. So OA is time AO, because integration of this is not going to change with the limit from dx is from here to there or that to that place. So it will remain the same, the time is same. So this one is correct, that the time is same. Now next we'll move to the other part of the question. So time will be same. Next is we have to find the velocity of two pulses are the same at the midpoint of the rope. If we think of the velocity is t over mu. As we can see that as mu is constant and t increases from A to O. A to O T increases, so the velocity will also increase from A to O. The velocity will increase from A to O. So towards the top, the velocity will increase, but then whatever the midpoint, whether moving downward or upward, the tension is same at the midpoint. So velocity will be same at the midpoint. That is because exactly the tension will be same at the midpoint. So velocity will be same at the midpoint. So this part of the question is correct. The wavelength of the pulse 1 becomes longer when it reaches A. So it says that when this will reach here, the wavelength will be more. Whatever the wavelength, when it reaches the lower point A, this point is O. Whether the wavelength will be longer, the velocity is frequency into wavelength, and because the frequency is constant, the velocity is proportional to wavelength. And we know that from O to A, the tension decreases, and V also will decrease because V is proportional to under root of tension. V will decrease. If V decreases, then wavelength will decrease, so lambda will decrease. So from O to A, as the wave pulse travels, it will decrease, the wavelength will decrease. So it is not reaches so longer when it has to decrease because the tension decreases, so wavelength will decrease, it will decrease. So that is not correct because it says it increases. It's longer. It says it is longer. It's not longer. It is shorter. So it is not correct. So option number 3 is not correct. So if you see the option number 4, the velocity of any pulse along the rope is independent of its frequency and wavelength. That is also correct. This is correct. So there are 3 answers correct to this question. Time, velocity at the midpoint, and the velocity of any pulse along the length is independent of its frequency and wavelength, because that depends on the tension, because the velocity of the pulse is basically the tension. It is a transverse wave. It depends upon the tension and the mass per length, and that is independent of that. So that is the answer. Okay, thank you.